Alright guys, welcome back for the second part of 2.1. So we're going to finish up that packet. So we're going to do the last 2 pages. So all vertices in this graph are even. So you can take my word for it, or you can sit there and count them all. That's entirely up to you. I really don't know why that's blurring right there, but that's weird. Anyway, can you find the sequence of vertices describing how to trace this graph? I don't want to do that. You can do that if you want, but there's some helpful hints. So here we go. So a network with exactly 2 odd vertices. You remember how we talked about in the last video or the last day's lesson, whenever you had that if you had no odd vertices or 2 odd vertices, it was traceable. Well, if you have 2 odd vertices, it's traversable, and either odd vertices, so pick one or the other, may be your starting point, and the other odd would be your ending point. That's going to make your life so much easier. Okay, so if you have 2 odd vertices, pick one of the odd vertices to start with, and you're going to end on the other one. So that will be so much easier to trace a path. Okay, now if you have no odd vertices, so no odd vertices, no odd vertices, that's really tiny, no odd vertices, you can pick any vertex, maybe your starting point. And the same vertex will be your ending point. So just start and finish at the same spot if you don't have any odds. Okay? And then please remember, any network with more than 2 odd vertices is not traversable. Okay? Now, if you have no odd vertices, this is called a Euler circuit. Okay? So no odd vertices is an Euler circuit. And because it begins and ends at the same vertex. So if you start and end at the same point, that's an Euler circuit. Okay? All right, that's the front of that. So we're going to go on the back and do some examples. Okay? So here we go. Which graphs below can be traced without lifting your pencil and without tracing any part of the line twice? That's one of those mind games that we told you about. Remember, I told you we can count the vertices, and then we can determine if it's traversable or it can be traced. Okay, remember 0 or 2 odd vertices. So what I'm going to do is go through here and label all my vertices with A, B, C, and D. And I'm going to do that for all of my shapes, okay? So I have A, B, and it really doesn't matter which order, but I just try to go in clockwise rotation. C, D, E. So if you want to label yours that way, then A, B, C, D, then A, B, C, D, E, and that's not going to be a vertex, that's just where those 2 lines just happen to cross over. Okay? Let's go A, B, C, D, E, F, G, H. Okay. All right, next, let's do A, B, C, D. All right, here, let's do A, B, C, D. Okay, then we'll have A, B, we'll go C, D, so we finish out this rectangle, and then E, F, G, H. All right, here, A, B, C, D, E, F. All right, now we just count. I'm going to use my purple pen to put the amount of lines coming out of each vertex. So A has 1, 2, 3, 4. Okay, B has 1, 2, 3, 4. C has 1, 2, 3, 4. D has 1, 2, 3, 4. E has 1, 2, 3, 4. So, we ask ourselves, first of all, is it connected? There's no disconnect anywhere. Then we ask ourselves, is there no or two odds? And we go, there's no odds. So this one is yes, it can be traced. Okay. So let's go to the next one. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. So this one connected. Yes. No or two odds. And it has more than 2 odds. So this one is a no. Okay, it has 4 odds. All right, moving on. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Okay, so this one connected. Yes. No or 2 odds. So let's see. It's got 2 odds. So the answer is yes. All right. So next, we do A, 1, 2, 3. B is 1, 2. C is 1, 2, 3. D is 1, 2. E is 1, 2, 3. F is 1, 2. G is 1, 2, 3. H is 1, 2. Okay, so this one connected. Yes. No or 2 odds. That's where it fails because it has 1, 2, 3, 4 odds. So the answer here is no. Okay, so what I want you to do is pause this and I want you to try the last 4 and then check them with mine. All right, guys, so here we are. So all of these had 3. So it is connected, and it had 4 odds. So the answer to this one is no. Here you had 1, 2, 3, 4 coming out of this one. 1, 2, 3 here. 1, 2, 3 here. 1, 2, 3, 4 here. There's 2 odds, and it is connected, so the answer is yes here. All of these had 2, but it is not connected, so the answer is no. Okay, because you can't get from A to E. They're 2 independent squares. Okay, even though their lines overlap, there's not a vertex there, so you can change direction. Okay, so here you have a 2, 5, 2, 3, 3, 3. It's connected, but it has more than 2 odds, so the answer is no. All right, very short lesson today. Let me know if you have any questions. Thanks. Have a great day.